Hey folks, welcome back to another midweek machining video. This one's going to be a little bit of a challenge, but I think it'll be kind of fun. We're going to go ahead and make a fuel tee like this out of aluminum and replace this plastic one with some very small design changes, which you'll see later on. The reason why I'm doing this is because number one, I can, and it's kind of fun to try at least. And number two, these are not available aftermarket in anything. Well, you can't even find the plastic ones, but certainly not in the aluminum variety. So we're going to try and make one. Now I'm going to have to make two straight fuel joints as well if this works, but I'm not going to show that, just this, because this is more complicated, A, and B, you've already seen this, you're going to be bored with the other stuff. So I've already made a drawing, and I've triple checked all the dimensions. So what this really is going to be is the first real chips we make on the new lathe. We're going to make it out of some 1-inch aluminum. It's the only thing I have. I don't have anything smaller. The biggest diameter rather on this is going to be a 1/2 inch. So first thing we're going to do is we're going to bring a piece that, length down to 1/2 inch. So again, the first thing we're going to do is turn this down to 1/2 inch. Because again, that's our largest diameter. And we'll work down from there where we need to be. So I hope you get something out of this. It's going to be kind of fun to do. Hopefully it works. I mean, because these plastic things, they only last so long. And I'll go over what machine it's for and what carburetors it's for at a later time. But, these things only last so long. And, then they crack and you got to replace them. And if they're not replaceable, then you got to make them. So why not just make them ahead of time and just get it done? Because I'm doing some work on these particular carbs. So let's see, we're going to go 1,000 RPM. And I think on feed we're going to go, I don't really have the gears set up exactly as what the legend, if you will, the charts shows. So it's going to be around 7 thou per revolution to rough this out, all right? Try turning it on. Be a 200,000 depth of cut. I realize this clip looks terrible, and I debated even keeping it in. But unfortunately, this is all the tooling I had available. I am assembling larger tooling for this lathe and also getting used to the lathe. Plus, this material is rather gummy, but it's still no excuse. It ended up working out in the end, but not necessarily the way to do it, but the way I ended up doing it. So I just kind of wanted to explain why you see it the way you see it. That's terrible. This cutter is not got the right profile to do that much of a depth of cut, so we're going to have to back that off. A little bit better, but not much. I think we're going to have to increase that feed, see if we can break a chip. Let's see if that works. Not really. This insert's terrible. Oh yeah, that's way too much heat. Well, I'm only roughing this in. It's aluminum. It's pretty forgiving rather, but insert's pretty crappy. I'm not going to change it for this though, because it'll do lighter cuts. So I'm just going to whittle this down. I'm going to make a little design change. Instead of going to 1/2 inch or 0.500 thou, I'm going to do this 550. I'll explain later. So we got 12 thou to go. All right, mucho bettero. Let's see, should be around 550. Well, it's a little under, that's okay. Like I said, this isn't important. It's around 550, it's around 546 now, but that's okay. It just has to be bigger in the center. We're going to end up cutting the ends down that go into the sides of the carburetor to a specific dimension, which it has to be right. We got to nail that. So first of all, we're going to face the end. And then what we're going to do is we're going to start whittling down one side of this. So essentially what we have to do is we have turned down a diameter at my offset or step is 615 thou from the end, and the overall dimension of that diameter is 353 thou. So the first thing we'll do is, and again, the step isn't critical, but we'll just touch off like this. All right, and then I'm going to set up I don't have a DRO, so we're going to set up a carriage indicator on the ways here. It's out of shot. And we're going to go in 615 thou and re-zero this. 1, 2, 3, 4, 5, 6, and 15. So I made this out of an old dial indicator that I had, and a couple of things. It works pretty well. I mean, it's a piece of crap Fowler knockoff probably, but it works all right for this. And a couple of magnets, as I said, that hold it to the ways. So now we're at 615 thou. We'll go ahead and we'll re-zero the calculator. Yeah, boy, my brain is fried today. Re-zero the indicator on 0. That way when we cut this in, we just come up to the 0 and then stop. You know, I got another idea too here. I just had a thought. Let's go ahead and support this. Put a live center in. I think that's a better idea. We're just going to use a number 3 center. And that is fine. Lock this quill down. Make sure we can still get in here. This is a different tool than what I would typically use in this situation. In fact, we're not going to be able to use this one, so we're going to have to change the tools. So hang on. I'm just going to use a neutral here because it doesn't really matter that the center section has a step or a 90-degree shoulder or not. It doesn't matter at all. In fact, it'll probably be neater looking and maybe even more functional if it doesn't. So the thing is, we're just going to do this. It's easier to reach the tool. Let's make sure it's on center, at least pretty close. Maybe a skosh up. Tighten that down, and we're good now. Yeah, that way we can reach in here without any trouble. And you know, we're still going to bring it in the 615. It'll just be a chamfer in there. There's no reason why that'll be a problem. And again, you will see why here in a little bit. But let's go ahead and touch off, and we're going to run this in. I want to go down to 353. We're about 550. So, like I said, roughly about 200 thou. So let's go and take, just do 60 to start with. And we'll come up to, actually, you know what? We really need to reset that indicator now. So we'll just kind of eye this in on the edge and then bring it up 600 thou. I just had a thought about that. We change cutters, we got to eye in, we got to reset the depth, or the length, I should say. Now we're back at 0, now we're good. 60 thou. All right, we're at 425 even. I'm just going to keep whittling it down, and I'll bring you back when we get to that final cut. 10 thou to go, slow to feed, and probably take it in 2 passes. This end needs to kind of get rounded over. There's going to be a groove, which I'm going to machine here very shortly, like now, in from the end that is very, very close to the end when the thing is done. So it's just one of these things where this thing, the overall length is really critical, because where this bottoms inside the bores of number 2 and number 3 carbs, respectively, there's a stop. So it can't move left or right. And that O-ring is only in that bore just a teeny bit. And it's a single O-ring style as opposed to a double like you see on some of the aftermarket fuel tees and fuel joints for like KZ1000s and the BS34s and things like that. So what we need to do is I'm going to get set up to do this groove. There's no reason why not. And then we'll knock this out, and I can spin it around and just do the other side. I mean, it's not terribly complicated, these operations, but you know, I was playing with this yesterday, the concept, and I ended up scrapping 2 parts because I made dumb mistakes. So I'm going to go ahead and square this tool first off camera, and then we'll come in and I'll talk about the groove and scrapping parts. All right, the groove is, according to my drawing, and I pretty much triple checked all these dimensions. The groove has to be an 88 thousandth width. This grooving tool is 80 thousandths width, so we're going to end up moving one side or the other 8 thousandths to take it off, the rest of it to make it the size. The offset from the end of the part is 66 thou. So if we touch off on this side of the part, we have to add that 80 thou to get to this side of the cutter. And that ergo leads me to the mistake I made on the other one. I had done one side and was parting the part off to length. And when I parted it to length, I forgot to accommodate the width of the parting tool, whatever that is. I gotta mic it up and add that to the equation. So essentially, I was cutting on this side of it, not on that side of it, which would have been the major width or diameter, if you will, of the part. So I said, oh well, you know, it is what it is. But in this case, I'm going to take a 3 thou feeler gauge and bring this tool in, because I really don't want to touch the end with the tool when it's turning. There we go. There's a good feel on the 3 thou. Back to tool off. So again, I know this is 80 thou. I measured it yesterday. So I'm going to set up my indicator, and then what we're going to do is we're going to come in 80, and then we're going to come in 66, because we got to be on this side of the tool to start. All right, so that's what we're going to do first. So here's 80. So now we're this side of the tool is lined up with that edge. Actually, not quite. We got to go 83 because we did a 3 thousandths feeler. There's 83. Let's zero this out again. And now we go 66 thou from here, and that will be where the outside edge of the groove is. So the distance between the end of the groove, the end of the part rather, and the inside of the groove is to dimension. But the groove being only 80 thou versus 88, we need to move that way. 8 more thou will take that extra off of the inside. Therefore, it'll be to dimension as well, okay? So now we got to go 66. And then this gets rolled over, and then you'll see the end of it when we get to that point. So it gets kind of rolled over the edge, but 66 thou is what I measured. So anyway, that's what we're going to do. I'm going to slow the speed way down for this, like down to 360, which is B2. Good. I think that should be pretty good. Yeah, for doing this. Definitely. Put tailstock support back in. Not too hard. Don't want to push the part up in the chuck and I'll be all off of my dimensions. All right, so how am I going to measure the depth of this is both off the dial, because I know how deep I need to go, and with a caliper. And the reason why I'm using a caliper is because my Starrett 120, I dropped it and it broke, and so it's up in Athol, Mass right now at Starrett, hopefully getting refurbished as we speak. So that's got to get repaired. So I have this caliper set for the depth of the groove, and we're just going to use it as a go, no go. But I kind of know how deep I need to go. It'll be like 47 thou on a side, so about 90, close to 90. A little over, but 45 and 45 being 90. So anyway, we're going to start cutting the groove. And I did this yesterday with this tool. It worked really well. So we shouldn't have any problems. We'll go ahead and touch off and then start measuring as we go in. There's 20, 40, 60, 80, then what I'm going to do is I'm going to come around like this, kind of at an angle, so I don't bump into the bottom of the tool and get a false reading. There it goes, right there. So that looks good, it feels good. Actually, it might be just a skosh big, so let's take a little bit off, just a skosh. Yeah, a little bit more actually. I think that's going to do it right there. Maybe a thou big or so, but I'm going to leave it there. All right, so there we go. Now we have to move in 8 thou, and we're going to take off the rest of it on the side, but we don't want to go too deep. That's one reason why I left it a little big, because of that. So I'm going to use a blue marker. Shove it in there, primarily over to that left side. Kind of like Dykem Blue, which by the way is AWOL. I can't find it anywhere. That's the second time I've lost that. I don't know where it went. It's great to be organized, isn't it? Now we're going to go 8 thou. That's about it right there. Now we just go down until we clean that up, and I found out yesterday that the chips end up going in there and scraping off the blue, so it's kind of a little difficult to see, but it's not impossible. And there we are. Now the one way I also checked the width of this is I figured out which number drill bit fits this. I believe it's a number 42. Because again, I don't have my Starrett, but it fits in there and just moves a skosh. So let's see if we can duplicate that, which we have. So it moves back and forth about the same, and it's about the same as this. I would say we nailed that exactly. I mean, I'm just going to say it, even if it's not true. The major diameter of the inside of that groove is right, based on the calipers. So this side is now done. So you don't need to see the other side. What I'm going to do is I'm going to do all the other side off camera. It'll be exactly as this, same as this, except you'll have this thicker center section, which I'll explain why here in a bit. And then we need to move over to the mill, which is where this thicker center section comes into play. All right, at this point, what we're going to do is, since I've got this end finished exactly the same as the other, we're going to drill a hole through it. What I did first was I parted this, but way long, and then measured that, and then put it back in and just whittled down the face by reading the dial indicator, because, you know, I can just do some simple subtraction to figure it out. So I'm about maybe 0.02 under, but I think that's going to be fine. Overshot it by 2 thou, but I think that's pretty close. So I think we're going to go with it, and we're going to drill a. This is a number 19, I believe, drill bit, and then we're going to follow it up with a reamer, which brings this to 178 thou. It's a little bit bigger than the hole in the original piece, but it's the closest reamer I had. I wanted to run a reamer through it to not only clean it up, but to make sure it's straight. The one I did yesterday came out straight, so I'm hoping this one will. And I got it really tight, and as you can see, I have some copper, or brass rather, in the jaws. But I got this sucker tight, so I seriously doubt we're going to have any movement. And, you know, because you can actually push the part or the workpiece into the chuck if it isn't tight enough with that kind of tool load from even a drill bit. So let's run this up to, I guess we'll just do it 1,000. I could go to 1,400 to max speed. Let's do that. And you know what? On second thought, we're going to keep it at 1,000. There we go. And there we go. All right, next step is I'm going to put a, I'm going to actually put a, what do you call, a threading tool in here, and I'm going to chamfer the inside of this, this groove on both sides. And That feels good. Now I'm going to soften it up. Off camera, I'll turn this around and do the exact same couple of ops to the other side. This is coming out. It doesn't finish our lathe work because we have to make the piece that goes in, you know, for the T part, hence the T, the name. But it gets us close. Actually, let me show you this. This rounded off part, you see how it's kind of a blunt? Very thin there. But I triple checked that. That is actually 66 thou from the outside edge to the inside of this groove. It just looks thinner because it's rounded over. So we need to duplicate that. Let's do it with a file. So let's do that. I'm up to 1,000 RPM again. That looks pretty much like it. We'll look at them side by side later on. But that really looks like it. And I don't know why it's made that way, but since it's made that way, we're going to make this one that way. So now we'll spin it around, do all that crap, and we'll come back. Okay, so here's the one I made up to this point. And here's this one. You can see we've achieved the proper length this time. The ends look pretty much identical. The diameters and the widths should be fine based on what I measured. And all we have to do now is do this stem part. So let me explain my idea on that, or my reasoning. Okay, this is a fuel T that will go to a BS34 type carburetor, perhaps others. And of course this is the one we made. Now you can see right off the bat the reason why I made it thicker than just going straight across and trying to put a little T on it is not enough material to do a press fit. If you look really close at this thing, you can see the machining marks where this was turned without a T on it, without a nipple, if you will, on it. You said nipple. You can see that there's no weld on that. Some of them are, but there ain't no weld on this at all. That's press fitted in. I doubt they even used any type of a Loctite or anything. That's just a pretty hard press fit. So that's exactly what we're going to do with this. Okay, I think I might mill a small flat. I'm not sure yet. I may do that or not, because I was thinking of making a shoulder on this piece that would go in, so it would bump up to that flat, but it actually may hurt us in the end. So I may just do it exactly like this one is. Drill the hole, ream it, and then I can make the nipple to fit, make it a few thou bigger, and then we'll press that sucker in a certain amount so it doesn't go too far. I mean, I can make a small little shoulder on it. It's not a big deal, so it won't go any further. It only has to be, you know, a few thou bigger, 10 thou bigger, whatever, which is what I probably shall do. And then, as you can see here, they have kind of the reverse on that. The bottom part that goes in is bigger than this part, which we may end up having to do as well, because that's the reliefs for the fuel line. They cut that down, so this must be the major diameter, the little part sticking out, and then the minor diameters are where the fuel line goes. I'm just going to duplicate the fuel line fitting end, if you will, on this one. Do it the same way. I'm not going to use those grooves. I'm going to use probably a button head tool to make a radius on the inside there, and then just hand file that end down to make it exactly the same. So I could probably just do a little step on here so it doesn't go too far in, and then we'll just figure out what size to make. Well, we need to make it this outside diameter for that size fuel hose, fuel line, but there's nothing that says we can't make the bottom just a little bit bigger, so there's a little bit of a ridge there or something. I don't know, I'm going to figure that out, but that's my logic on this. We're just going to press it in. As long as we get a really good hard press on it, you know, like a 2-3 thou crush, I don't think there's going to be a problem. Well, I had to turn the fan on, no choice. It is hot, hot, hot again. So anyway, I'm going to probably do all this work in collets, not in a drill chuck. They're a little bit more accurate. So what I have is the edge finder in a collet, and we're just going to edge find off of the vise because the part obviously is in the vise. And I know this major diameter here, so we're just going to be able to calculate the center of that. Then we'll come off the edge of the tool as well. Edge of the tool, yeah, we'll come off the edge of the part. So the first thing, again, we're going to do is edge find into the back of the vise. It doesn't matter if you do the back of the front, but I generally like to do the fixed jaw. There that is. Whoa. You got away from me there. All right, so at this point, I got to put an indicator on here because I still got to get a freaking DRO for this thing. Just an XY DRO. I already have that Z one. Okay, our edge finder is 200 thousandths, and we're already on the inside toward the center of the part. So whatever we have to calculate, we have to subtract 100 thousandths, which is half that. The overall diameter of that is 547, so half is 273, so we need to move in 173, because like I said, we're already 100 thousandths in. So this is where we go 100, 50, 60, 70, 2, 3. That takes care of the X. I'm sorry, the Y, so now we have to do the X. So we're going to go off the edge of the part because we know that overall dimension as well, and then we'll just go in halfway. Okay, so now we're going to load up a center drill in a collet, then the drill in a collet, and then the reamer in a collet, and we'll finish this hole up. Okay, the drill I'm going to use for this is actually a 6 mil. I can't make this the exact same size of that outside of the original one because I don't have a reamer that size. So I have 6 mil and then I have a reamer that's 249. It's a 1/4 inch 1 thou under. So that's where we're going to make the other part too. So, you know, we have some flexibility here, in other words. And that's about it. We're hitting the bottom. All right. So we're pretty clean. Let's just hammer the reamer through. Same deal, only different. That way we can kind of control where the chamfer is. Just kind of break that edge. Sometimes hand work is the best. I could take that on the dance floor for a couple of spins, but I think I won't. Okay, now that my air compressor's running, that's better. I'm gonna go over to the lathe. I'm not gonna film any of this. You've already seen the lathe work. It's just a very simple part. So I'm gonna go make that simple part, and then we'll figure out if we can. We might just be able to push it down with the quill here. This thing is probably pretty apt to adapt to do that. All right, adapt, I don't know. And then get it seated. At least we could get it started. In other words, we get it started straight, and then shit, we can put it in the vise with the soft jaws and have this thing just go drive it home, you know? All right, so here is the fuel inlet that I machined. Looks pretty good. And I'm 3 thou exactly. I measured that hole with a small bore gauge. And it did cut a little bit big on that reamer, which is weird, because it was in a collet, but oh well. And made this exactly 3 thou bigger. So it's got a good crush to it. And I just chamfered the end by hand because this end is bigger than that end, so it's kind of hard to chuck, so oh well. Anyway, what I did was I degreased it. I'm going to degrease it again because I just touched it with my grimy hands again. And I'm going to go ahead and put some Loctite 640 on it. No reason not to try it. I also made a pusher tool, this guy here, which goes over top of the opening like that, which will help square it off. In the chuck is in a collet is a drill extension, which got a very square flat edge. Something I made a long time ago for a special project, I assume. And so this is how it's going to be set up, and then we'll come straight down on it. Try to push it in with the quill. Sort of wants to try to go in, so it probably will. Try to keep her straight. Of course, quill's locked. This will help keep it square because, you know, we are, you know, square with this hole. So if it's square up here, then it should be square with the hole. In other words, the part is square with the hole. Let's see what happens. Okay, baby, go, go, go. Oh yeah, she's tight. All right, now it went through and it's partially blocking that hole, but I kind of engineered that in because I'm just going to run a drill through the hole again. Clean that out, because I just made it long. I just didn't know how long the depth would be, but let me tell you something. That sucker is in there. I had to put some serious force on that to get that in. All right, so that's what she looks like. All right. So that's the fuel inlet side of it. You can kind of see the light shining through there, no problemo. And then that is the other side of it. And then there is the fuel delivery side of it. See down that bore pretty good too. So it's all nice and clean. We'll make sure that it's got no loose chips or anything. You can see a little bit of junk in there, but like I said, we'll wash it out later. Once this Loctite. Once the sleeve retainer cures, like tomorrow, we'll just wash it out with some soapy water and blow it out, and it'll be good. All right, so where were we on this? Because it's been a minute. That's right, we're gonna see how this works. Here's our piece right here we just machined, and I got some old O-rings in it. I just put 2 of the old ones in, because I don't want to put the new ones in. If this doesn't work and I gotta dig them out, I could damage them to put them in the plastic one. So anyway, this is carb 2, this is carb number 3. Okay, so number 2 and number 3. This is the location in which these go. My main objective is to test this to see how it lays inside there. In other words, is it kind of crimped in there? Because you got to look inside here to really understand it completely, to get a picture of it. You see inside the hole, the bore, there's like these little flats. And these little flats are where the end of whatever tube, whatever T you're using, bottoms out. So I'm assuming, for example, on the black one, that's probably why these are kind of radiused. So maybe it gives a little bit more distance in, because there isn't a whole lot of room here between the end of this, of course, and the groove for the O-ring. And likewise, there ain't a whole lot of depth here on these holes to that little step. Maybe 5 mil at the most, if that. So what I wanted to do was see how these would go together, and then how what aligns these guys, if I can actually say the words, is the bracket, this angle bracket. Now you can see right there from, look, this is not going to work. So look at this. So let me put a couple of screws in here. I'll show you what I mean. All right, what I was trying to say before was what sets the spacing between the carbs is this angle aluminum on the back side here. So I got 2 screws in, 1 in each. And if we take a look at this, I mean, this sucker moves back and forth a lot. And this is exactly, and actually maybe slightly, it is slightly bigger than the plastic one. But you see how that moves back and forth a lot? And then when you move it over toward carb number 3, you got a little issue here, because you can actually see the O-ring wanting to peek out. You see that? And again, this black one, this black plastic one, okay, I tried this one in the exact same test, and it moves back and forth pretty much exactly the same. And I made this one to this size. This is about maybe 5 or 6 or 8 thousandths longer, actually. Not much significantly, of course, but this I made it to this size. So this is not going to work. I'm not going to trust this, because you know what we have is a situation where it's just going to probably, and that's what may have happened with this as well. Besides, you know, degradation of the O-rings, you know, deterioration over time, this thing moves over to the side, and because it's shrunk a little bit or something, it's the O-ring's too close to the edge. So yeah, that's not going to work, and I don't like the plastic one either. So what are we going to do? We make yet another one. So this would be the 3rd version, or the 3rd try. And let me show you the differences here. You're going to see them right off the bat, most likely. I had a problem with this one with clearance to number 3 carb. You can see right there that there's, you know, it's very close to the body of the carb, near where the float bowl meets. And so I ended up putting it back in and machining some of that back so it would clear. Even when it was pushed over to the left, it was still very close. So I made a new one and I offsetted it. So you can see it's longer on this side, so obviously it would go to number 3. And, well, it would go this way. And I also made this like 50 thou longer. I was running around yesterday after seeing this, doing errands and stuff, and I'm thinking about it going, it's kind of hard to measure, but I think it's about 50 thou. So I made it 50 thou longer, which is almost a 16th. And that'd be 25 thousandths on the side. And it seems to work pretty good. Let me show you. Okay, so as before, I've got like this other one. I have 2 of the old O-rings on it. Out of the 6, luckily 4 of them had some, they weren't split at least. They weren't completely falling apart. So just for testing purposes again. And you can see this one moves back and forth just a tiny bit. I'd say 20 thou maybe, so 10, maybe 50, maybe 30. 15 on the side, which is what I intended it to do. No, really, I did. And you can see on the sides here that there is going to be no chance of that O-ring either side peeking out. And with a good, and you know, with a good set of O-rings in here, I think it'll be fine, because I made the grooves like on this one as well, and the diameter of the barrel here and here exactly the same as the black one, the plastic one here. So I duplicated all those exactly. So the offset from the ends and everything else is the same. This one's just longer. Again, this one's 50 thou longer than that one, and of course that one as well. I think it's better. I think it's a better design. It's not jammed up against the aluminum in there. It moves freely. It moves very freely right now because these are the old O-rings. Once we get the new O-rings in, it'll be good. And I think this is going to be a much better option for the fuel inlet on these carbs. Now the only bad part is now I got to make 2 of these, but this is going to be super easy. This is a fairly complicated part to make. I think when I tested this, they were a little bit shy too, so probably add about 15 thou to the overall length, and that'll make sure that these 2 are also, you know, these joints, this would be the T, this would be the joint, are appropriately spaced out, therefore deepest in each side of the carburetor bore for the fuel inlet. All right, so let's go do that, and then I guess we're going to be done. All right, folks, this is not my traditional outro, but I really didn't shoot one, so here's a couple of clips of the fuel tee and the fuel joints in situ, and you can watch the ZX10 video to show them in action. They do work real well, no leaks, and I'm real happy with the outcome. So I hope you enjoyed the video. Hope you got something out of it as we close out this one. Thanks for watching. We'll catch you on the next video.